vectors video. Mathematical definition of a vector: an element of the real coordinate space. Basic vector, one of a set of vectors that is a linear combination, can represent every vector in a given vector space. Column vector or row vector, a one-dimensional matrix often representing the solution of a system of linear equations. And finally, coordinate vector in linear algebra, an explicit representation of an element of any abstract vector space. When are two vectors parallel? Parallel vectors. Two vectors are parallel to one another if they can be represented as a scalar multiple of each other. Note: a scalar can be negative. The direction of a vector can be represented as the angle of a triangle. So, as shown in the picture, it will be tan of the angle. In this case, the direction will be determined by tan inverse of y over x, as shown by the formula. Of a vector will be the length. In this case, we can see in the drawing that the length is determined by the hypotenuse. So we can do, like in this case, we have the vector 5, 6, so we can do hypotenuse is equal to root of 5 squared plus 6 squared, and in this case the length of the vector will be square root of 61. The formula, as we can see, is xy vector, so the magnitude will be root of x squared plus y squared. When are two vectors perpendicular? Two vectors are perpendicular when their dot product equals 0. So in the example, we have the vector -4, 4, and 1, 1, which their dot product will equal -4 times 1 plus 4 times 1, which will equal -4 plus 4, which equals 0. In this case, these two vectors are perpendicular. Definition of dot product. If you have vector m and n, you will have dot product of m and n equals magnitude of m times magnitude of n times cos of the angle. We calculate the dot product of two vectors in this way, which is the definition of the dot product shown before, where the A equals the magnitude length of the vector A, B is the magnitude length of the vector B, and well, that symbol is the angle between A and B. So we multiply the length of A times the length of B, then multiply by the cosine of the angle between A and B. David Hilbert created the mathematical concept of Hilbert space. After he generalized the notation of Euclidean space, it extends the method of vector algebra and calculus from the two-dimensional Euclidean plane and the three-dimensional space-to-space with an finite or infinite number of dimensions. A Hilbert space is an abstract vector space possessing the structure of an inner product that allows length and angle to be measured. Gibbs was an American scientist who made important theoretical contributions to physics, chemistry, and mathematics. As a mathematician, he invented modern vector calculus. independently to the British scientist Oliver Heaviside, who carried out similar working during the same period. Oliver was an English self-taught electrical engineer, mathematician, and physicist who adapted complex numbers to the study of electrical circuits, invented mathematical techniques for the solution of differential equations equivalent to Laplace transformations, reformulate Maxwell's field equations in terms of electric and magnetic forces and energy flux, and independently co-formulated vectors analysis. The vector equation of a line is r equals a plus a constant b. A is a general point on the line and b is a vector parallel to the line. So if they tell you find a vector equation for the line that goes through 1, 0 and minus 3 and it's parallel to the vector 2, minus 4 and 5, the vector equation of a line will be as follows. X, y, and z equals 1, the vector 1, 0, minus 3 plus the constant times the vector 2, minus 4, 5 as shown on the video. Equation of a line. If you have the vector equation of a line as shown on the screen, then you can transform this into the parametric equation of a line. So you take each of the rows, in this case like x equals a1 plus the constant plus b1 and y equals a2 plus the constant plus b2, and this will give you your parametric equation of a line. Screen, you can see an example of the definition of the dot product that was shown before. Here we can see the most important formula of calculus. So as shown in the drawing, we can see an origin, which is the O seen, the vector v and the vector a. So to find OA, we use OB plus BA, and to find BA, we rearrange this and it's OA minus OB. The same happens with the other drawing. Now we can see the Christian equation. So the Christian equation is rearranging the parametric equation by arranging it all to have the t value. So as shown with an arrow on the screen. Unit vectors may be used to represent the axis of a Cartesian coordinate system. For instance, the unit vectors in the direction of the x, y, and z axis of a three-dimensional Cartesian coordinate system are the ones shown on the screen. The slope under the vector slope in vectors is a tan inverse of an angle, which will give you the direction. So if you have the vector 2, 3, the slope in this case will be tan inverse of 3 over 2, as shown on the screen. Now we can see the equation of a line of 2 dimensions. In this case will be xy equals a1, a2 times t, which is the constant, and the vector which is parallel, which will be b1, b2. And for 3 dimensions we can see the same, but with another a, with another b, and with c. Dimensions relation between b vector on the vector equation of a line and the slope of a line in the equation of a line is that they both tell the direction of the line. The common use of parametric form is to use elimination and solve for a variable and to find the intersection. Parametric equations, however, illustrate how the values of x and y change depending on t as the location of a moving object at a particular. Finally, it's important to highlight that the parametric vector t is used to find another point on the line.